Good afternoon, everyone. My name is Massimo Cardarelli. I am the VP of Sales Engineering here at Lightpath, and welcome to our Wholesale Lunch and Learn. We're going to cover some material here today amongst the network, our reach, NearNet, as well as bring on Sienna to talk about some of the investments and augments we've been doing to the network with Sienna. So with that, I'm just going to dive into this and really give an overview of our network and what have we accomplished over the last 12 to 13 months at Lightpath. What you see on the screen right now is a map of the infrastructure that was pretty much acquired and spun off from the AUSA with Morgan Stanley's investment. And it was predominantly a New York Metro, Long Island, and New Jersey-based fiber footprint. It's dense fiber within the metro area. And what we did is we took this asset and we started building off of it roughly 10, 11 months ago and making some significant investments. On the right-hand side of the screen, you're going to see that with the New York Metro asset, we expanded into Boston immediately. We acquired some asset in Boston, added roughly 80 plus route miles of fiber and over 100 buildings to be on net through an acquisition. And with the acquisition, we also tied it back to the New York Metro core with multiple 100 gig links. So it's one ubiquitous network throughout the footprint. In addition to that, we made some significant investments within the footprint here in the New York Metro and Boston. In New York, we densified the borough of Queens. You could see it's probably a little low on that map there, but we spent a significant amount of dollars and we're making big investments in Queens to the tunes of over 100 route miles of fiber being deployed and well on the way. We added some diversity by adding infrastructure across the Mario Cuomo Bridge to give us some diversity and resiliency between Westchester County, Connecticut, the northern asset into New Jersey, and ways of bypassing New York City. We also did an investment of adding roughly 50 plus route miles of fiber down in the Princeton, New Jersey area to densify our reach down towards Hamilton and Trenton, New Jersey. And in addition to that, we pretty much did additional investments in Boston. In Boston, we took the 80 plus miles that covered roughly downtown Boston, Cambridge, and Somerville, and we kind of expanded out. And the expansion added roughly 50 plus miles, route miles of fiber, and it allowed us to get out to Middlesex, Lowell, as well as Waltham, and create a nice loop within the Boston market. In doing that, you'll see here in the New York metro area and up in the Massachusetts, we had the fiber footprint, so now we started leveraging the infrastructure to build out a core network and augment existing core networks. So the blue dots you see here are head ends that we are able to leverage within our footprint. That's down here in the New York metro area. Up in Boston, with that expansion we did out to Waltham, Middlesex, and Lowell, we took some facilities, some space within existing third-party facilities and created core nodes. Back to the New York Metro, New Jersey, our engineering team has been busy and we've upgraded roughly 22 head ends are active today with multiple degrees connecting each one of these. And we did this by leveraging the Sienna RLS architecture. Up in Boston, we took the fiber footprint and we established pretty much 5 core nodes, POPs, within the market to allow us to sell all our products and dense services. So when you look at 1 Summer Street, we tied 300 Ben Street, Waltham, 115 Second, 55 Middlesex, as well as Markley up in Lowell. So what this enables us to do is we deployed the Sienna architecture, RLS, and it allows us to leverage the dense fiber footprint as well as Sienna and offer anywhere from 10 gig to 100 and 400 gig services, client handoffs today, as well as growing up to 800 in the future. In addition to the investment here, we further expand. And let me go on this. We further expand, and now you're going to see some red dots and red lines on the maps here, right? So those initial 22 nodes that we deployed and turned up in the beginning of the year here in the New York Metro, New Jersey, Long Island region, we also did 5 of them up in the Massachusetts area. With that, the red dots represent expansions of phase 2, which is currently being deployed and should be up and running in June of this year in the New York Metro, that's going to add another 32 head-end locations into the core footprint. Up in Boston, we're going a little deeper. You see the red lines and a couple of red dots there. What we're doing there, we just announced recently, we're going to be doing 70 plus miles of expansion and essentially build from Boston, downtown Boston, to establish presence in Needham, Northborough, Westborough, and Marlborough, and tie it all back to our Waltham pod. So this way we have the ability to offer our full suite of services out to the data centers out west. You'll also notice a little dot between our Waltham and Cambridge area there. It's Watertown, Massachusetts. We're going to be establishing a node in Watertown as well. So the idea here is dense fiber footprint, big investments in the market, deploying Sienna RLS throughout the market to allow us to do big bandwidth, large pipes for the customers, and continue to expand outside of the regions. Final slides here are showing down to Ashburn. So in expansions up to Boston, densifying the New York Metro, Long Island region here, we also had asset fiber that took us down into the Ashburn campus to get reach into the data centers. We recently signed a deal and are taking asset underway to go from Piscataway down to Ashburn on that red path you see on the map. And that's essentially going to allow us to provide an additional redundant route to Ashburn, leveraging something that not many other providers are currently utilizing today. There is that legacy Transcom route that is out there that others use as a DC bypass. This is in addition to that route. It's diverse from that route, and it provides a unique pathway from the northern New Jersey, New York City area down to the Ashburn area to connect to the facilities in Ashburn. This is well underway as well, and we should have this route up and running, leveraging Sienna by September, October of this year. That's the planned target, to have it fully functional, as well as we're going to continue and upgrade our existing infrastructure on that eastern path, establishing a node in Philadelphia with some redundancy in our Philly node at 401 North Broad to tie it all up and make this all one ubiquitous network, leveraging our Sienna architecture. On the right, again, just a quick recap of where we are. 18,000 plus route miles of fiber throughout our footprint where we stand today. I think we're approaching over 19,000 actually. Over 12,000 on-net locations. We're building significantly, like I mentioned, over 100 miles in Queens, 54 in Princeton. We're connecting multiple third-party data centers. We're connecting cable landing stations as well as critical cloud provider locations. Up in Boston, we have over 200 plus route miles of fiber since we got the initial 80. Over 100 on-net buildings, and we're adding buildings every month to the footprint up there as well here in the New York Metro, and the tune of somewhere between 50, 60 total buildings on a monthly basis are being added. And again, the expansion down to Virginia is going to allow us to offer a unique route and also big bandwidth pipes down to the Ashburn area to connect to those cloud providers and get to the DRTs, the core sites, and the Equinexes of the world that folks are trying to reach to in a diverse route. I know I covered a lot here, and there'll probably be questions at the end. But for now, I will hand it off to Kevin Murray to talk about some of the programs that we're doing to bring those buildings on net, like I mentioned.
Okay, so what I'm going to talk about today is what Lightpath has done in terms of our standardizing our carrier NearNet program. And one of the important reasons that we've had to get in front of this and standardize the pricing to our NearNet locations is to ensure that, for our carriers that have, that do their quoting through their homegrown systems or through other quoting systems, that we're returning pricing when they go into search for a building and want to determine if we can provide serviceability. And if we did not have this put into place in advance, then we may not have the opportunity to quote these buildings as, it's not done in the same manner as the enterprise sales where the rep would be in contact with a potential customer. So in addition to the 12,000 plus buildings that Massimo referenced, what we've done is we've used our GIS tools to determine the distance and costing for an additional 46,000 NearNet buildings within our footprint. So in addition to the construction that we're doing to, increase the amount of buildings that we can reach, we've also enabled these buildings to be quoted in an automated fashion to also provide additional buildings for our customers to quote. In essence, this increased our number of standard price buildings by over 500%. We went from around 12,000 to about 60,000. And then in addition to that, we also have an additional 150,000 buildings that we have not provided pricing to, but we also have added them to our NearNet building list. So if you're being provided that NearNet building list, you'll be able to see the additional buildings that can be reached. They didn't necessarily fit the parameters of the standardized program that we were trying to put out there, but what they do put it on the radar that it is a place that we are willing to build to. It's just not at a fixed price out of the gate. These building lists can be accessed through some quoting tools that we use. MasterStream, ConnectBase, and NDA are three of the providers that we put these buildings in pricing out through. Or we can also provide with a flat file to you directly that you can load into your own internal systems or use manually as you do your quoting. In the pricing itself is structured to mirror our standard on-net pricing. So essentially, it's structured in a way that we have payback thresholds that need to be met. And once we cross over where that payback threshold has been met, it kind of defaults to our standard pricing. So essentially, as you move up to higher terms and bandwidths, then you're essentially, in many cases, getting on-net pricing for that NearNet build. And that's all that I have. So we can move on to the next speaker.
Hi there, my name is Joe Shapiro. I'm the VP of Core Transport PLM at Sienna, and I'm going to be taking you through the products that Lightpath has selected to offer the services through the build-out that Massimo and Kevin just went through, some of the benefits that those products provide to Lightpath and ultimately to their end customers. So this first slide just goes through the challenges associated with driving optical layer innovation and the requirements that our customers and their customers are looking for. So increasing capacity and scale, so maximizing the amount of bandwidth that can be provided across fiber assets. And the industry trend to address that is using coherent technology. So this is the technology that's used on the transponders that deliver the capacity on the network. So using coherent technology is kind of the de facto approach for a transport solution like this, and evolving that coherent technology to get the maximum capacity per wavelength, therefore the most economical delivery of those services. Network visibility, so having visibility into the network to be able to predict challenges and better serve customers. So integrated instrumentation is being enhanced as part of the offer, both the RLS platform as well as the transport platform that's running on top of it, Wavelogic-based solution. A reduced footprint, of course, make the platforms as dense as possible. Therefore, you can offer the maximum amount of capacity in a minimal amount of RUs, taking up less real estate and reducing costs associated with footprint. Simplifying operations, so being able to turn up the network as fast as possible and add a maximum amount of automation to that process in order to get services turned up faster with less human intervention, less prone to error. And then, of course, make the platforms and the system as open as possible. So from a Lightpath perspective, not locking into a particular vendor to give them flexibility around best-in-class solutions and helping provide a little bit of leverage into our customers back into us as a supplier to keep their costs as competitive as possible. This slide provides a view of how the technology is evolving in order to address that. The requirements along the top are similar to what has previously been mentioned, which is scale, reduce cost per bit, operational simplification, agility, and allow our customers to innovate in terms of their service offering. The way that the industry is approaching that is through investment in the appropriate amount of technology. So from a domain controller perspective, have that software layer in place that can manage this network in an optimal way to to be able to turn up services as quickly as possible and optimize the flexibility there. In terms of the transport layer, keep the footprint as small as possible, make it as energy efficient as possible, moving to next generation silicon technology in order to achieve that. And then from a disaggregation perspective, allow our customers like Lightpath to use best in breed solutions for every layer in the network. In this case, we're talking about layer 0, the pure photonic layer, and then layer 1, the transport layer, disaggregated solution to be able to use best in class products at each layer. So the products that are actually being used to deliver the services that were mentioned are two families of products. The RLS platform, which stands for the Reconfigurable Line System, that's operating at layer 0. This is the amplifiers and the reconfigurable add-drop multiplexers that provides that infrastructure on which to offer services. And the Reconfigurable Line System is best-in-class platform. It's brand new, newest technology across the board, and one that's really been designed from the ground up to provide the attributes previously mentioned, and one that's got a lot of momentum in the industry in terms of really snapping to that best-in-breed, lowest footprint, easiest to operate, maximum capacity platform to deliver the services required. And then running on top of that, which would be the coherent modems, is what we call them, the transponders. Multiple different solutions are available. I believe Lightpath is using both the Wave server family of platforms. So this is a DCI pizza box approach to delivering those services. And that modem technology is also available in other form factors, depending on the platforms that are in place, a 6500, for example. Both of those would provide the optimal solution in terms of the capacity per wavelength and per fiber to, again, keep the solution being offered to their end customers at the top of the line. So the Reconfigurable Line System, the RLS, some of the attributes that are associated with the RLS that ultimately led Lightpath to this selection and allows them to optimize the services they can offer their customers are the advanced programmability and openness. Platform is a couple of years old, and the operating system on which it was based was designed to be able to keep it as open as possible and make it as programmable as possible, and built on modern interfaces in terms of how you talk to the box and how you operate the box. So it gives our customers and their customers a lot of flexibility in terms of how they can kind of tune the service offering. And as part of that, leveraging those infrastructure, the software infrastructure, we've been able to make the platform simple to deploy and operate. So using things like zero-touch provisioning, integrated OTDR, the turn-up process has been simplified as much as possible, and the hooks are in place to make it as automatable as possible for kind of future speed to turn-up capability, and then ultimately make it as dense as possible. So a lot of work went into the physical form factor of the platform. We are leveraging 600 millimeter depth for some of the configurations to really keep the number of RUs to a minimum and pack the maximum amount of available capacity in the minimal number of RUs for real estate savings and costs associated with that. This slide talks to the Wavelogic technology. So this is the coherent modems that Ciena has provided and Lightpath is using. Wavelogic 5E is the industry-leading, most current modem technology available. It's been around since March of 2020. It was the first coherent modem that delivered up to 800 gig per wave. I think in the Lightpath network, the average capacity per wave being used is north of 600, if I'm correct, which really ensures kind of the maximum capacity across those fiber assets and the ability to offer services to their end customers based on an existing wave, which generally equates to quicker time to market to turn that around. It's been an extremely successful product. Over 30,000 of these modems have been shipped in the last couple of years across all customer segments for the benefits that it provides. So the capacity per wavelength ranges anywhere from 800 gig to 200 gig and provides the top of the line spectral efficiency to maximize the capacity of the fiber assets. And there's an infrastructure in place across the software tools and the planning tools and then the host platforms to make it as easy to deploy as possible, and other tools that are in place to really allow you to squeeze the maximum amount out of every wavelength in order to keep kind of your costs as low as possible. And one thing to note is the Wavelogic 5E modem has integrated FIPS 140-3 compliant encryption solution integrated directly into that modem platform. So future encrypted service offerings are going to be available based on the infrastructure that's already in place. Okay, and this is my last slide, just kind of a wrap up across Ciena's holistic coherent optical portfolio. So across these four pillars, the coherent modems, Wavelogic 5, and we've got lots of other variants of that to ensure that Lightpath is armed with the optimal modem depending on the service offering required. You have multiple different host platforms in place across the layers, so RLS, industry-leading layer 0 solution, and then riding on top of it either Wave Server 5, 6500, or even route switch platforms with integrated coherent technology provides a breadth of service offering on the photonic line system, purpose-built, best-in-breed, open photonic line systems to deliver the capacity across the fiber, and then the software tools in place to kind of wrap it all together through the entire life cycle, planning, deployment, as well as network management. So that was my last slide. I'll turn it over to the team to cover any of the Q&A that came up throughout the presentation.
Thank you, Joe. Jumping in over here. So there, just so everybody's aware, there is a Q&A piece on the bottom there. You'll be able to submit any questions. We do have a couple of questions that came into the chat here, so I'll take the first two here. First question that came in is, what are the interval times to turn up a NearNet location? It does vary based on region, right away, and location. What you do in New York City, in Manhattan, for example, varies from what happens in Brooklyn and Queens and out in Long Island, or even in Boston for that matter. But for that, we usually give a range of 60 to 90 days for a turn up of the NearNet building. That means that location falls within a distance of our backbone, and it could be up to 4,000 feet from the backbone potentially. And, we provide some aggressive timelines to get the fiber into the facility and turn it up. So a 60 to 90 day range is what we would normally quote for a NearNet location. Second question that came in was, is 400 or 800 gigs available across the Lightpath network? And to answer that, yes. Obviously, Joe just went through some detailed slides here on RLS, the technologies. He touched on the Wave server and the capabilities, and the answer is yes. So we laid out the architecture across our head ends, and whether it's up in Boston or down in the New York Metro and down to Ashburn, we do have the capability on the line side running up to 400 and 800 gigs on links. And I believe right now, Joe, correct me if I'm wrong, client handoffs right now are just set at maximum of 400 gigs and 800 gig to come in the future. Is that correct?
That's correct. Yeah, the current Wave server platform supports up to 400 gig per client handoff. The platform itself, we have a plan of record to deliver new modem technology that would include 800 gig interfaces on the client side as well.
All right. Thank you, Joe. We have another question that popped in here. And Kev, this is probably going to be for you. The ask is there a minimum bandwidth required for a NearNet location?
Currently, we have 10 megs is the lowest that we go on our switch products. So that's what we have for the standardized pricing. So I'd say that's about as low as we'd want to go and commit to a build. And then it looks like we have another question that came in asking if we could have standard contracted rates. And we do provide the customers with standard pricing. And if it is something that you wish to have written into your MSA or into like contractual form, then that's definitely something that we can work with our legal team to provide. Then there was another question in here from an old colleague. So thank you, Dan. We appreciate the well wishes.
All right. So that's all the questions that I see at the bottom here. I don't see any other ones popping up. I just want to thank everybody for taking the time to joining the call, listening into the Lunch and Learn. I want to thank Joe and Kev for joining and helping with the presentation here. So with that, I'm going to say have a good day, everybody.
Thank you.
All right.
Have a
Thanks.
good day.
Have a great day, everyone.